So today we're going to look at different types of explicit equations, both geometric and arithmetic, and different ways that you might see them. So the way that I taught you last class is the way that our textbook CPM shows how to do it. And it's really great because it mimics how we learned how to find equations of tile problems and how to find equations of lines. However, when you go on to your Khan Academy, you're going to see it different ways. Now, the great thing is that Khan Academy will mark it correct regardless of which way that you use, because it is correct using the technique y equals mx plus b for arithmetic and using y equals a times b to the x for geometric. However, I'm going to show you a couple other ways that you might see sequence equations as well. So here we go for some arithmetic ones. So we know that arithmetic sequences are an adding or subtracting pattern. And here's our example: -4, -1, 2, 5. So we go ahead, I jump right to the positive ones because it's always easier for me to see what that pattern is. So I know 2 plus 3 is 5. I double check it. -4 plus 3 is -1. -1 plus 3 is 2. So remember, it does have to work for all of them. If it doesn't work for one of them, then you know immediately that there's not a pattern that we can create an equation for. So this one is an adding pattern. And so we work backwards by doing the opposite operation. So we're going to do -4 minus 3. And we know that our zero figure is -7. So we know arithmetic is a line and it's y equals mx plus b. However, you might see it like this. Instead of a y, you might see t of n. Now, if you see an n, that means that it is specifically talking about a sequence, and there is no zero. It starts with 1. Now, once again, the letter in front of what we would normally say y equals mx plus b, in this case, it's an n. Notice it's a t of n and an n, which is function notation. The letter in front of that, the number in front of the letter, is our pattern. So we know that we're adding 3, so that goes in that same spot. And we know that our b is our 0, which is -7 in this case. So the only thing that's changed here, instead of y and x, it's t of n and n. So other than that, it's using the same technique that we have. The t of n and the n just tell you this is a sequence instead of just a line that continues forever in both directions. We know a sequence starts with 1. Okay. Now, the new notation uses the first term as opposed to the 0. And it's kind of nice because you don't have to work backwards to find the 0. All you need to know is the pattern, and you can just plug in your numbers into this equation. The equation looks a little funky. It's the one where most of the world uses for sequences, and it's just something that you have to have written down and memorized to use. So it's a of n is equal to m times the quantity n minus 1 plus a of 1. Now that little sub, you say a of, and basically that means that the next number is the slope times the number minus 1 plus the first term. So in this case, a of n is what we normally call our y, or our t of n that we just learned. The m is still the pattern, and a sub 1 is our first term. So we're using that instead of our 0 term. So we know the pattern. We know the pattern's 3, and we know the first term is -4. So everything else we're going to leave exactly the same. We're just going to replace your m and your a of 1. Everything else stays the same. So in this case, the same sequence we just did is a of n is equal to 3 times the quantity n minus 1 minus 4. So it uses, once again, the first term in the pattern as opposed to the 0 in the pattern. And that's something that you can write on a flashcard and memorize. It's something that you can write down because you get to use your notes. But you just need to know that this is also an equation for arithmetic, and it's also an explicit equation. Explicit simply means if I give you an x or if I give you an n, then you can just plug it in and find out what term that next number is. So once again, the pattern is your m, and your a sub 1 in this case is your first term. So that's all you're replacing are those two items. Okay, now let's go ahead and take a look at the same thing for geometric. So we know that geometric is a multiplication or dividing, and we know that we always write it as multiplication pattern. And we learned that if we can't obviously see that multiplier, we just go the next term divided by the previous. So here we have 15, 45, 135, 405. So we take any of those two numbers and we go next 135 divided by previous 45, and we can go ahead and see that our pattern is times 3. So we're going to go ahead and work backwards. 15 divided by 3 is 5. So we know that our 0 term is 5. Once again, all we need is our multiplier, which is 3, and our 0, which is 5. Now, our equation is the same. We're simply replacing y and x with t of n and n. So in this case, t of n is equal to 5, which is your 0, times your pattern 3 to the nth power. Once again, our 0 comes first, which is our a, and our pattern comes second to the nth power, and that would be our b. Okay, now we're going to go ahead and look at it in the new notation. Once again, we're using a of n and a of 1, and we're going to be using the first term. So here's the formula for a geometric multiplication pattern. A of n is equal to a of 1 times b, but in this case, instead of the nth power, it's to the n minus 1th power. So once again, a of n is simply a substitute for y, or t of n, and a of 1 is the first term, and the pattern stays the same. So all we're replacing is a of 1 and b. So in this case, a of n is equal to, our first term is 15 times 3 to the n minus 1. And so just, you will be seeing it both ways when you're going Khan Academy, and you should be familiar of what both of these are. So once again, this is an exponential function, and we use y equals a times b to the x power, or in this case, a of n is equal to a sub 1 times b to the n minus 1. And for our arithmetic, we're basically doing a line, y equals mx plus b, or we're doing a of n is equal to our pattern times n minus 1, and then plus our y-intercept. So ladies and gentlemen, once again, you're going to see this on Khan, and we're going to be able to look at these and see that both of them will give you the correct answer as you're plugging in numbers and finding those numbers in the pattern. First term and our pattern are the two items that you plug into that. Once again, you're just going to memorize this pattern or have it written down really well and circled and highlighted so you can use it on our final.